Hey everybody, this is going to be a video on the beginning portion of the Chemistry Unit 3 curriculum. We are going to be discussing everything that has been covered in class this week, since I believe there is going to be a quiz for some classes tomorrow. So here we go. First, we're going to be discussing the atomic radius, and it's basically the measure of the size of an atom, specifically the distance from the center of the nucleus to the outermost electrons. So as you move across a row in the periodic table, each element gains one more proton and one more electron. The added proton increases the positive charge, pulling the electrons closer. So when the electrons get closer to the nucleus, the atomic radius decreases, so atoms get smaller from left to right. So now we have valence electrons and shielding. Valence electrons, you should know this already, are the outermost electrons of an atom, the ones in the highest energy level. These are the electrons involved in chemical bonding, like forming molecules or ions. Remember that when atoms are bonding or coming together, they're trying to find stability. And basically they're sharing their electrons until one of them achieves the stable number of 8. Remember that 8 is the magic number in chemistry for this sort of stuff. So electrons are being shared in between atoms when they bond, as they seek a total of 8 electrons to achieve stability. So to identify how many valence electrons an atom has, there's a short trick that you can use based on the periodic table. So the group number on the periodic table often equals the number of valence electrons. So in group 1, there's typically 1 valence electron, and group 17, 7 valence electrons. So that's basically it for valence electrons. Make sure you understand that. We've discussed this in class multiple times before, but now we're moving on to shielding, which is a fairly new topic. So basically shielding is when inner electrons block or shield the attraction between the nucleus and the outer valence electrons. So imagine you have an atom, the nucleus in the middle, all the energy levels up until the outermost energy level with those electrons. The outermost energy level with those electrons contain the valence electrons. And shielding is when the core electrons, or the electrons in between the nucleus and the valence electrons, shield or block the attraction between the nucleus and the outer valence electrons, since we know that protons attract electrons and protons are in the nucleus, and obviously electrons are in the energy levels outside of the nucleus. So shielding, again, is when the core electrons block the attraction between the nucleus and the valence electrons. And this happens because electrons in lower shells repel outer electrons, reducing the effective nuclear pull they feel. So, valence electrons and shielding connection to the periodic table. So, valence electrons increase by 1 across a period, and they stay the same down a group. The shielding effect stays roughly constant across a period and increases down a group, since there are more inner shells with more electrons. And then the result on the atomic radius decreases across a period, since there's a greater force on the valence electrons, and increases down a group. Z effective. So Z effective, or the effective nuclear charge, is the net positive charge felt by an electron in an atom. So how much positive charge is an electron feeling or experiencing in an atom, specifically the valence electrons? So how much positive charge is a valence electron experiencing from the nucleus? So even though the nucleus has many protons pulling electrons inward, the core electrons block some of that attraction. Like we said, shielding is what blocks some of the attraction from the nucleus to the valence electrons. So the Z effective is going to be Z minus S, where Z is the number of protons and S is the number of core shielding electrons. So that's how we calculate Z effective, and make sure you understand what it exactly means. It's just how much attraction is being blocked by the shielding electrons. So Z effective connection to the periodic table. So basically, the Z effective increases across a period, and it slightly decreases or stays similar down a group. And then the Z effective connection to the radius, or ionization energy. We'll discuss ionization energy on the next slide. But basically, the for the atomic radius, the ZEF is smaller since electrons are pulled in tighter, and then for a lower ZEF, the atomic radius is larger, and for a higher ZEF, for ionization energy, it's higher, harder to remove electrons, and then the opposite for the lower ZEF, Z effective. Ionization energy. It's the amount of energy required to remove one electron from an atom in a gaseous state. In other words, it measures how strongly an atom holds onto its electrons. For a neutral atom, X, let's call X, in the gas phase, this is how we're going to write the ionization energy. This was probably one of the more difficult things, the harder things we learned in class. This was what we learned today. Make sure you understand it. Please reach out to your teachers if you have any remaining questions. But the ionization energy measures how strongly an atom holds onto its electrons. So if we're trying to pull an electron away from an atom, like a valence electron, when we're trying to pull it away and give it to another atom, this is basically how much force, I guess, would have to be done to pull this electron away. I'm not entirely sure how to explain this to you guys. I would encourage you guys to do a little bit more research or learning of this by yourself, because again, this was a quicker video. I also have to study for some tests, but I hope I did my best in explaining everything, and thank you for listening, thank you for supporting. Make sure to subscribe to my YouTube if you haven't. At 100 subscribers, I'm thinking about making MA2 videos for you guys, so please tell your friends to subscribe, anybody else you know, and enable notifications to not miss out on any future videos. When I post a video, you guys will not miss out because you'll get a notification when I post a new video. So I don't have to send it out to everybody. You can just get the notification and check my YouTube. So thank you guys again. Good luck on the quiz. Good luck in chemistry. I'll continue to make these videos, and maybe I will see you guys in my future MA2 videos. Thank you so much. Have a good night.